Good day, guys. Welcome back to MSCC online tutorial. In this tutorial video, we want to solve some Liouville problem. So I'll just explain some basic things that we need to know when it comes to Sturm Liouville. Now, the question before us is to find we want to find the eigenvalue and the eigenfunction of this Sturm Liouville problem. Y prime prime plus lambda y equals to 0. So what you need to do without wasting time is to write your characteristic equation, which is m squared plus lambda equals to 0. Now what we want to solve is we want to see at which point of this equation we are going to have a real solution, that is a non-trivial solution. What is a trivial solution? A trivial solution is a solution that equals to 0. So we want to see at which point of this are we going to get a non-trivial solution. So now let's start with case 1. So when we are going to test for three cases when lambda is less than 0, that is lambda is a negative number. So what you do is you let lambda equals to minus k squared. Why are we saying lambda equals to minus k squared? This minus here is emphasizing that lambda is always negative no matter the value of k, because here any number squared will always give us positive, but then multiplying by minus will always give us minus. So now let's continue. So what you need to do is put your k in this characteristic equation. So if I put my k in my characteristic equation, I will have m squared minus k squared equals to 0. Now I want to get the value for k. I want to get the value for m squared equals to k squared. So to solve that, we find the square root of both sides. So m equals plus or minus k. Now don't forget we are in a differential equation. So when you have distinct roots, your answer will always be, so my y of x equals to a constant, that is c1 e raised to power the first value of k, let's say k positive, kx, plus another constant c2 e raised to power the second value of k, that is minus kx. Now, having done that, the next thing that we need to do is to test this point. We have been given this boundary. So when this thing implies when x equals to 0, y equals to 0. So we are going to put it here. So watch closely. When x equals to 0, y equals to 0, that is y of x equals to 0. So here it will be 0 equals to, if I put 0 here, anything raised to power 0 is 1, obviously c1 plus c2, because if I put 0 here as well, I will get c1 plus c2. So I always advise that before you go to the next step, get value for either c1 or c2. So let me get value for c1 here. So c1 will be equals to minus c2. Now once you get this value, write your y of x in terms of your new value, so that my y of x will be equals to, now I've gotten c1 to be to be minus c2. So anyway I see c1, I'll put minus c2. That will be minus c2 e kx plus c2 e minus kx. Now that is pretty good. So now this is my new y of x. The other boundary, the other interval, that is y of pi equals to 0, that is when x equals to pi, y equals to 0. So I will put it here now. When x equals to pi, y equals to 0. So y of x equals to 0 when x equals to pi. But okay, let's write that. So that will be minus c2 e k pi plus c2 e minus k pi. So what we need to do here is to just do a simple arithmetic. You can factor out c2, but then I want you to see that this value, this e k pi and e minus k pi, cannot be equals to 0. So I'll multiply both sides by either e minus k pi or e k pi, any of your choice, it will work. Multiply both sides by e k pi, in this place e k pi. Now having done that, you will see that this side is still 0 equals, now using the law of indices, I'll multiply both sides. So this one will give me minus c2 e 2k pi law of indices, and this one will be plus c2, because here I will have e minus k pi plus k pi, which will be e raised to power what, 0, and n raised to power 0 is what, 1. So from here we will see that 0 equals to, now c2 is common, I can decide to factor out c2, so I will say that c2 into bracket, this is 1 and this is minus e2k pi. Now we can see that in these two conditions, now we see that if you multiply two numbers and their product give you 0, is either one of them equals to 0. So, but obviously here c2 equals to 0, and this 1 minus, okay, let me say comma, e2k pi is not equals to 0, because for any value of k, this cannot be equals to 0. If you try to equate it to 0, you will see that e2k pi will be equals to what, 1, is not equals to 0. So here, since c2 equals to 0, that means what, c1 equals to 0, c1 equals to 0, c2 equals to 0. Now we have a trivial what, solution. We have a trivial solution in this case, so we cannot use that condition when lambda is less than 0, that is when lambda is negative. Now the next thing to do is to check when lambda equals 0. So when lambda equals 0, we are still going to check. Now put 0 in your characteristic equation. So this will be m squared, this will be m squared equals 0. Now it implies that what, m equals to what, 0 twice. Now we have reason for putting this twice, because now we believe that finding the square root of anything should be plus or minus, though we don't have minus 0, but then this is what we are going to use. So and then when we have a twice factor or root in differential equation while solving, our y of x we take this form. It will be c1 plus xc2. So here now we are going to put our condition again, y of 0 equals to 0. So 0 equals to c1 plus, if I put 0 here, 0, which implies c1 equals to what, 0. Now I haven't done that. I said earlier that we should always write our y of x in terms of what, c1, that is our answer, our new answer, the new answer that we get. So my y of x will become, now if I put c1 to be 0, it will become x what, c2. Now the second condition, we are going to test the second condition, that is when we have y of pi equals to 0. So testing that, I will have 0 equals to what, pi c2. You know x is pi, y is 0. So now between pi and c2, which one can be equals to 0? Of course pi is not equals to 0, because we know the value of pi. That means c2 equals to what, 0. So if c2 equals to, we have c1 equals to 0 and c2 equals to 0, that is a trivial what, solution. We cannot use it, it's not valid, because we are looking for a point where we get a non-trivial solution, that is when our values of constant, the two of them will not be what, 0. That's why we have our eigenvalue and eigenfunction. So the last step is to check when lambda is greater than 0. So we say what, let what, lambda equals to what, k square. This is to emphasize that lambda will always be positive. Yes. So if lambda equals to k square, we'll go back to our auxiliary characteristic equation, or auxiliary as the case may be. So let me write it, m squared plus lambda equals to 0. That's our characteristic equation. So I'll put k square here. So it will be m squared plus k squared equals to what, 0. So if x squared equals to k squared equals 0, what do we have? We have m squared equals to what, minus k squared. So to get m, you find the what, square root of both sides, but take note, you are finding the square root of negative here. So m will be equals to what, plus or minus ki, because of the complex, plus or minus ki because of the negative square root. So now we are almost there. So the next thing to do is, now from here you will see that we need to put this in our differential equation form, that is our y of x. How will our y of x come out? Anytime you have a complex here, so your y of x will come as e raised to power the real number times x into bracket a constant cos the imaginary plus a constant sine the imaginary. Let me just write that out. So it will be, but then our real number here is 0, so e raised to power 0 is what? 1. That one is gone, so we just need to write a constant cos what? Kx, that is the imaginary that is here, plus a constant b sine kx. Now what we need to do now is to plug in our what condition, that is y of 0 equals to 0. And so if I put 0 anywhere I see x and put 0 anywhere I see y, that is y of 0, the way we have been doing it, you will see that here if I put 0 here, this will become what? Cos 0, and we all know that cos 0 is what? 1, so this will be a plus sine 0 will be what? 0. Automatically my a is what? 0. So I told you that you should write your what? Y of x in terms of your new answer. Now a is equals to 0, so I will write my y of x equals to what? B sine kx before I test for the second condition. Now because my a is 0, so from here now the second condition, y of pi equals to 0. So anywhere I see x I put pi, anywhere I see y I put what? 0. That is y of x. Here I have 0 equals to b sine k pi. Now this is where we are going to draw our conclusion. Now here you will see that for any value of k, sine k pi will always be 0, because sine of multiple of pi will always be 0. If you multiply this by 2, if k equals to 2, if k equals to minus 2, if you multiply it by this, sine of the answer will always be 0. So obviously here our b is not equals to what? 0. Since, which implies what? You can say which implies sine k pi equals to what? 0 for all integer values of what? K. That is, if k equals to plus or minus 1, plus or minus 2, like that, it will always be what? It will always be 0. So here now we have gotten a non-trivial solution, because here my constants are not all equals to 0. A equals to 0, but b is not equals to 0. So this is where we are going to get our eigenfunction and our eigenvalue. So now to write my eigenfunction, let me write my eigenvalue before writing my eigenfunction. So my eigenvalue, lambda n, it is the value of lambda that gave the what? The non-trivial solution. Recall that check here, we said let lambda equals to what? K square. So now I'm using lambda n, so I'll write my k in terms of what? N. So my eigenvalue is what? N squared. Now what about the eigenfunction? The eigenfunction, it is that function that gives you the 0 when your constant is not equals to 0. This is a quadratic this is a trigonometrical function. It is the function that gives you what? When you have a non-trivial solution. You know, here gives 0, this sine k pi, from here sine k pi equals to 0. So when my b is not equal to 0, so my eigenfunction will be what? Sine what? Sine k, now we said we should write k in terms of n. So let me strike this, so it will be sine what? N. Now I want to write it a function of what? What are we dealing with? A function of x, so it will be sine what? N x. So my eigen, let me write them out. Eigen value lambda n equals to what? N squared, and my eigenfunction is what? Sine nx. So that is how to solve Sturm Liouville problem. Just make sure that you understand how to do it. That is, we are looking for a non-trivial solution when we have a non-trivial solution. That's where our condition lies. So we have to test when lambda is negative, when lambda is 0, when lambda is what, positive. We can all see that here now we have a non-trivial solution, because here my constant, the two of them are not equals to 0, because here my b is not equals to 0. So this function that gives me the 0 will be my what, again function, and the value of lambda that gave the what, non-trivial solution, that is lambda equals to what, k squared, that will be my what, again value. So we are just writing it in terms of what, in terms of n, because this is a dummy variable. So thank you very much for watching. Make sure you share with your friend, subscribe to this channel so that you get our latest videos. Like, subscribe and share. Don't forget to drop a comment. Thank you.